At Earth's distance from the Sun lies a fragile zone where temperatures, light, and chemistry align perfectly to sustain life. But what if this orbit, this rare balance, belonged to someone else? What would Mercury, Venus, Mars, or even the gas giants become if they moved into the very position that makes Earth alive? Would any of them stay stable? Could any of them create oceans, air, or even life itself? Let's bring every planet of the solar system to Earth's orbit and see which ones bloom and which ones break. We begin our incredible journey with Mercury, the smallest and densest of the rocky worlds. In its natural, scorching orbit, Mercury is a planet of extremes, its surface temperatures swinging wildly from over 400 degrees Celsius to minus 170. It's a sun-baked crucible constantly bombarded by solar radiation with an almost non-existent atmosphere. Now, picture Mercury in Earth's orbit. The intense solar radiation it usually endures would be significantly softened, allowing its superheated surface to gradually cool. This cooling would stabilize its metallic crust, reducing the extreme thermal stresses that cause its surface to crack and shift. The planet's surprisingly large molten iron core, which currently generates a weak magnetic field, might even see a temporary strengthening of this protective shield as it cools and solidifies further. However, Mercury's fundamental flaw remains its size and gravitational pull. Its weak gravity simply cannot hold on to any significant atmosphere. Any gases released by residual volcanism or outgassing from its interior would quickly escape into the vacuum of space, stripped away by the solar wind. Over millions of years, this tiny world would freeze solid, becoming a silent iron relic. Perhaps in the deepest, permanently shadowed craters near its poles, a faint dusting of ice might persist, a frozen whisper of its brief, cooler existence. Mercury's fate here is a stark reminder that size and the gravity it provides can be the ultimate arbiter of a world's destiny. Next, we confront Venus, often called Earth's twin, yet a twin gone horribly wrong. In its current orbit, Venus is a runaway greenhouse nightmare, shrouded in thick sulfuric acid clouds that trap nearly twice the sunlight we receive. This infernal blanket turns the planet into a 460 degrees Celsius furnace, hot enough to melt lead, with atmospheric pressure 90 times greater than Earth's. But what if Venus occupied Earth's gentle orbit? The solar energy it receives would be nearly halved, a dramatic reduction that could initiate a profound transformation. Its upper atmosphere would begin to cool, causing the dense, reflective clouds to thin and break apart. Surface temperatures, while still hellish, could drop significantly, perhaps to around 200 degrees Celsius. This is still far from comfortable, but it represents a substantial step back from its current extreme. Yet, Venus's true curse isn't just the heat, it's the sheer density and composition of its atmosphere. Packed with carbon dioxide and sulfuric acid, it creates an unstoppable greenhouse effect. Without plate tectonics to recycle carbon back into the planet's interior, or a strong magnetic field to protect against solar stripping, this thick, toxic blanket would persist, preventing further cooling. However, high above this inferno, at altitudes of 50 to 60 kilometers, a remarkable possibility emerges. Simulations by NASA's Goddard Institute for Space Studies suggest that these upper cloud layers could host regions of mild temperature and pressure around 30 degrees CI. Here, water droplets could potentially float for months. Some astrobiologists even theorize that microbial life could exist there right now, hidden within the mist, metabolizing atmospheric chemicals. Imagine the first signs of alien life not on a new planet, but in the sky of an old one, given a slightly better chance. Further out, the red planet, Mars, takes Earth's place. At first glance, this scenario seems like a cosmic redemption for the dusty, cold world. Mars would suddenly receive twice the sunlight it's accustomed to, a dramatic increase in energy. This influx would trigger a cascade of changes. Its polar ice caps, currently composed of both water ice and frozen carbon dioxide, would begin to melt rapidly. This melting would release vast quantities of carbon dioxide and water vapor into the thin Martian atmosphere. A thicker atmosphere would quickly form, trapping more heat and initiating a localized greenhouse effect. Temperatures could rise significantly, potentially reaching near 20 degrees Celsius in some equatorial regions. With warmer temperatures and increased atmospheric pressure, liquid water could become stable on the surface. Rivers might flow again, carving new channels, and shallow seas could return to the ancient basins that once held vast oceans. For a brief, glorious geological moment, Mars could look blue, a vibrant world teeming with potential. However, this hope is tragically temporary. Mars lacks a global magnetic field. Its iron core long ago solidified, ceasing the geodynamo that protects Earth. Without this vital shield, the solar wind would relentlessly strip away this newly formed atmosphere. The precious water vapor and carbon dioxide, so crucial for its brief revival, would be slowly but surely blasted into space. This atmospheric erosion would occur over mere hundreds of thousands of years, a blink of an eye in cosmic terms. The planet would inevitably dry out, freeze, and die again. Perhaps for a short, vibrant period, primitive microbes could arise in its fleeting oceans, adapting to the new conditions. But they would ultimately vanish, leaving behind only fossil echoes of a second, heartbreakingly failed beginning. If you're wondering what would happen to Earth in the orbits of these other worlds, the inferno of Mercury, the storms of Jupiter, the cold of Neptune, you can find that story in another video. I'll leave a card here for you to explore that equally fascinating and perhaps more terrifying scenario. Now, let's turn our attention to Jupiter, the colossal gas giant, the undisputed king of our solar system. Place this behemoth at Earth's distance, and the sun's increased warmth would finally penetrate its upper cloud layers. This added energy would brighten its already vibrant colors, intensifying the swirling reds, oranges, and whites. It would also stir more violent and frequent storms, making its iconic Great Red Spot seem even more furious. But Jupiter isn't just massive, it's a cosmic disruptor. Its immense gravitational pull would wreak havoc on the asteroid belt, located between Mars and Jupiter. Countless asteroids would be pulled out of their stable orbits, hurled inward toward the inner solar system. Collisions would rain down on nearby planets, rewriting their surfaces in a chaotic ballet of impacts. Yet, Jupiter's own moons would experience something truly extraordinary. Europa, Ganymede, and Callisto, currently frozen worlds locked in icy embrace, would begin to thaw. On Europa, the increased solar radiation, combined with the intense tidal heating from Jupiter, could melt through its thick ice crust. This would reveal the vast subsurface ocean beneath, confirmed by data from the Galileo mission to be over 100 kilometers deep. In that dark, liquid sea, heated by internal forces and now warmed by the sun, microbial life might finally awaken or flourish. If life could exist anywhere beyond Earth, thriving in a sunlit, albeit still deep ocean, it might be there, beneath Europa's shimmering, now thinner, ice. Ganymede and Callisto, also possessing subsurface oceans, would undergo similar, though perhaps less dramatic, transformations, offering even more potential havens for nascent life. Next, we encounter Saturn, the golden giant, renowned for its breathtaking, majestic rings. These iconic rings, composed of billions of icy particles and dust, are a spectacle of the outer solar system. But at Earth's orbit, their fate would be sealed. The increased solar radiation would warm them relentlessly, causing the ice to sublimate directly into a gas. The rings would not survive. They would slowly evaporate into a faint, ethereal vapor halo, raining microscopic particles down onto the planet's atmosphere. The iconic crown would vanish, leaving Saturn looking strangely bare. Saturn itself would remain a gas giant, its immense atmosphere of hydrogen and helium swirling with greater intensity due to the added solar energy. However, one of its moons, Titan, would undergo a truly spectacular transformation. Currently, Titan is a frigid world, colder than Antarctica, shrouded in a thick nitrogen atmosphere and dotted with lakes and rivers of liquid methane and ethane. It's a fascinating alien landscape, but far too cold for liquid water. Bring Titan into Earth's orbit and everything changes. The increased warmth would cause those hydrocarbon lakes to evaporate, replaced by vast bodies of liquid water. Data from the Cassini mission has already revealed a vast subsurface ocean of liquid water beneath Titan's crust. In the warmth of Earth's orbit, that ocean could breach the surface, forming real seas, real clouds of water vapor, and a hydrological cycle remarkably similar to Earth's. With a thick atmosphere already in place and the presence of complex organic chemistry, Titan, not Mars, could become the first truly habitable world beyond Earth, a vibrant ocean world ripe for the emergence of biology. Further out drifts Uranus, the enigmatic ice giant, famous for its extreme axial tilt. Its axis lies nearly on its side, a staggering 98-degree tilt that gives it utterly extreme day-night cycles. 40 years of continuous sunlight followed by 40 years of perpetual darkness at its poles. This unique orientation already creates bizarre weather patterns. Now, imagine Uranus in Earth's orbit. Its year would dramatically shorten from 84 Earth years to just 365 days. This rapid orbital period, combined with its extreme tilt, would collapse its seasons into one chaotic, violent loop. For half of its new year, one pole would face constant, intense daylight, absorbing immense amounts of solar energy. Simultaneously, the other pole would be plunged into an equally long period of absolute darkness and extreme cold. The result would be monstrous planet-spanning winds, far more powerful than anything seen on Earth. Boiling clouds of methane and hydrogen would churn, creating frozen supersonic storms that would dwarf any hurricane in history. With no solid surface and no clear boundary between its atmosphere and its icy, fluid interior, Uranus would become an eternal storm machine. The relative calm and frigid stability the planet might have found in the distant reaches of the solar system would be utterly shattered here. It would be a world of perpetual, violent, atmospheric upheaval, a beautiful but terrifying spectacle of raw planetary power. Finally, we arrive at Neptune, the deep blue sentinel guarding the outer edge of our solar system. Even in its distant, frigid orbit, Neptune possesses a tilt similar to Earth's, about 28 degrees, which gives it gentle, albeit extremely long, seasons. It's a world of serene, deep blue, punctuated by massive, transient storms. Move Neptune inward to Earth's orbit, and those seasons would remain, but the added sunlight would inject an unprecedented amount of energy into its atmosphere. The methane clouds that give Neptune its iconic deep blue color would thin and become more dynamic, potentially turning the planet a paler, more ethereal shade. Yet that same energy would fuel winds beyond human comprehension, far exceeding the 2,000 kilometers per hour already observed. The Great Dark Spot, a storm system the size of Earth, would be dwarfed by new, even more colossal tempests. The calm, majestic blue giant would transform into a world of whirling, supersonic hurricanes, faster and louder than any storm ever recorded. Neptune on Earth's orbit would be a breathtaking sight, a vibrant, dynamic world of unparalleled atmospheric fury. It would be beautiful in its raw power, but utterly terrifying in its destructive potential, a testament to the sheer energy a star can impart. So after this grand exchange, what have we learned? Among all the planets, only a few show promise. Venus might hide life in its clouds. Europa and Titan could awaken as new ocean worlds. Mars might bloom for a moment before dying again. The rest, Mercury, Jupiter, Uranus, Neptune, remain forever uninhabitable. The Goldilocks Zone isn't magic. It's a coincidence of balance: sunlight, atmosphere, magnetic protection, chemistry. Shift any one of those and paradise collapses. Perhaps the most crucial lesson is this: the Goldilocks Zone isn't a magic bullet. It's a coincidence of incredibly delicate balances. It requires the perfect amount of sunlight, a stable atmosphere, robust magnetic protection, and the right chemistry. Shift any one of these critical elements, and paradise collapses into an inferno or a frozen wasteland. The orbit doesn't make the world alive. Rather, the world's intrinsic properties make the orbit matter. Earth is not just in the right place, it is also the right kind of planet. Which of these planets do you think holds the most potential to become a second Earth if given this extraordinary chance? Share your thoughts and theories in the comments below. If you enjoyed this mind-bending journey through the solar system's alternate realities, hit that like button, subscribe to our channel, and ring the notification bell. Because next time, we'll explore an even bolder idea. What happens when we try to build life ourselves, from the ground up?